Okay, this lesson is on differentiability, and the focus of this section is to determine when a function fails to have a derivative. The word differentiable means you are able to take a derivative or the derivative exists. If it's not differentiable, that means the derivative does not exist. It says, using the grid provided, graph the function f of x equals the absolute value of x minus 3. We should know that that is the absolute value graph shaped like a V, moved to the right 3. And the slope, if you recall from last year, the absolute value is whatever number's in front. Well, that number is a 1, so we go up 1 over 1, up 1 over 1, up 1 over 1. So there's the right side. And then the other way, it's just a mirror image. Okay, it says, what is f prime? And when you see that, so that's derivative, as x approaches 3 from the left. Well, as x approaches 3 from the left is this side of the graph, and we're just looking for the slope. Well, the slope's down 1 over 1, so the slope is negative 1, therefore the derivative is negative 1. What is the derivative as x approaches 3 from the right? Well, as x approaches 3 from the right is the right side of the graph, and that's the slope of up 1 over 1, up 1 over 1. So that's the slope of m equals positive 1, so the derivative is positive 1. Is f continuous at x equals 3? Well, I can go all the way across without lifting up my pencil. Yes, it is. Is it differentiable at x equals 3? No, it is not. The rule for differentiable is similar to the rule for continuity. In order for it to be differentiable, the limit as x approaches 3 from the left of the derivative has to equal, actually, it's not the limit. It's the derivative as x approaches 3. Hold on. The derivative as x approaches 3 from the left has to equal the derivative as x approaches 3 from the right has to equal the derivative at 3. Well, what is the derivative at 3? You could not draw a tangent line there. It's a cusp. It's a pointy place. You cannot have a derivative at a pointy place. The derivative from the left is negative 1. The derivative from the right is 1, so they do not equal each other. They're not approaching the same thing, so it is not differentiable. Okay. It says graph f of x equals x to the 2/3. Off the top of my head, I don't know what that looks like, so we're going to go to our calculator. X to the 2/3. Looks like that. So here it says describe the derivative of f of x as x approaches from the left and the right. Well, it's decreasing as I approach from the left, and it's increasing as I approach from the right. From the left it's negative, and from the right it's positive. So because they're not equal, it has a cusp, and because it has a cusp, there is no derivative. It says, suppose you found f prime of x equals 2 over 3 cube root of x. What is the value of the derivative when x is 0? We're actually going to do that on our calculator. To find a derivative on your calculator, new document, no, add calculator. We go menu, we are in calculus. We want to find the derivative at a point, and our value is 0, and it's 2 over 3 cube root of x, 2 over 3 cube root of x, 2 over 3 cube root of x, 2 over 3 times the cube root of x. Whoops. X. Oh, look, it's undefined. And then if we were to work that out with the definition of the derivative, it would also be undefined. And it's undefined, again, because the derivative as I approach 0 from the left is negative on this side. The derivative as I approach 0 from the right is positive on this side, and therefore at 0 it has no derivative. It's undefined. Okay, it says graph the cube root of x. That's the swimmer man. He looks like this. Describe the derivative of f of x as x approaches 0 from the left and the right. Well, as I get closer and closer, like if I were to draw tiny little tangent lines, it would do this, and then it would do that, and then all of a sudden, at 0, the tangent line is vertical. At a vertical tangent, what's the slope of a vertical line? It's undefined. So you cannot have a derivative at a vertical tangent line. So suppose you found, I'm just kidding, go back over here. The derivative is this. What is the value of the derivative when x equals 0? I actually found the derivative of the derivative, which was still undefined. But if I plugged it in, I would get 2 over 0, which is undefined. I read the problem wrong the first time. And then this one, the derivative of this is this, the 1 over the 3 cubed root of x squared. What's the value of the derivative when it's 0? Well, it's 1 over 0, which is undefined. You cannot take a derivative at a vertical tangent line. And then we're going to stop right there on this video. And the next video we'll talk about other derivatives not from graphs.